Okay, so we are going to continue with problem 10. So problem 10 asks, we're given a line that intersects a certain sphere in 2 points. So we want to find the distance between these 2 points. So the line that we're given is r of t is equal to -1 plus 2t, 1 plus t, and -1 minus t. And the sphere is x squared plus y squared plus z squared is equal to 9. So we just take the components and we plug them into the x, y, and z components. So when we do this, we get -1 plus 2t squared plus 1 plus t squared plus -1 minus t squared is equal to 9. And if we solve our t, we will get the times where this line and the sphere intersect. So for the first one, if we just open it up, -1 plus 2t times -1 plus 2t is equal to 1 minus 4t plus 4t squared. This is for the first one. For the next one, 1 plus t times 1 plus t is going to be equal to 1 plus 2t plus t squared. And then for the last one, -1 minus t times -1 minus t is going to be 1 plus 2t plus t squared. Now when we put this all together, we get 1 minus 4t plus 4t squared plus 1 plus 2t plus t squared plus 1 plus 2t plus t squared is equal to 9, which then gets us to 6t squared plus 3 is equal to 9, or 6t squared is equal to 6, or t squared is equal to 1, which means t is equal to plus or minus 1. So these are the 2 places where we intersect the sphere. Any questions about this so far? Again, once we find our t, we can find our first point by just plugging in this t. So P1 is going to be, so let's say that that's when we plug in the +1. So we are going to get -1 plus 2, which is 1, and 1 plus 1, which is 2, and -1 minus 1, which is -2. So that's our P1. Our P2 is going to be, so now we're going to plug in the negative ones. So we're going to get -3, and then 0 and 0. So the question is, what's the distance between these 2 points? So the distance between P1 and P2 is the square root of -4 squared plus 2 squared plus 2 squared is the square root of 16 plus 8 which is the square root of 24. And that's the answer. Any questions? Yes. No calculators, no. Any other questions? Yes? No calculator. Yeah. Yeah? Yeah, I'm gonna put up the answer key tonight for the section homework. Yeah. Yes? I don't know if the other professors are gonna tell that to their students, so I'm not gonna say how many questions are on the test. But I will say it's, let's say, between 5 and 9 or something. 5 and 9. No, no multiple choice. Just these type of questions. Once, yeah. Yeah, you will get partial credit. Most importantly is to do the steps. It doesn't matter if you like the question about the calculator. If you get the arithmetic wrong, we won't care that much. If you get a step wrong, we will care more. Yes.
So for like degrees, can we write this like cosine something and don't actually write?
If it's obvious what it is, like for pi or pi over 2, try to write down what it is. But again, it won't matter that much. We care much more about the steps and less about getting the numbers correctly. Any other questions? Yes? It's going to be from 6:15 to 7:30. Okay. What I can say, I guess, about the questions is all the professors took the exam and we try to do it in 1/3 of the time, and I think everyone managed. So that's the number of questions. You can try to guess how many questions there are, maybe based on that, but okay. Okay, so for number 11, match the equation with the name and the graph. So the first one is z is equal to 2 minus x squared. Any ideas what type of shape this is going to be, what type of graph we're expecting, and why? So we don't have a y coordinate, so we expect something that is symmetrical in the y-axis and kind of looks like a parabola, but that extends to infinity. So the only shape that we have that looks like that is C. So the answer for A, let's do the answer for A is C. Anyone remember what it's called? Yeah, parabolic cylinder. For the same reason that a cylinder is kind of called a cylinder, it's it's an ellipse that we extend to plus and minus infinity. So if you take a parabola and you extend it to plus or minus infinity in one direction, you get a parabolic cylinder. So that's A, and so this is the answer. Okay. Anyone can tell me what B looks like or what it is? Yeah, G. And the reason it's G is because if we move the Z to the other side, so now we have negative Z on the other side, and then we subtract the negatives on both sides, we get x squared plus y squared is equal to -1 plus z squared. And that -1 tells you that you're a hyperbola of two sheets. The two sheets comes from the -1. And the fact that you're a hyperboloid is comes from the fact that the z is on the other side and is positive. So that would be G. And that would be hyperboloid with two sheets. Anyone can tell me what C looks like? B, yes. So C is B, because C, you can do the same, you can make the same steps, but now you're moving the y to the other side. So you get x squared plus z squared is equal to 1 plus y squared. And now your 1 is positive, so you're in a paraboloid of only one sheet. And but it's going in the y direction. So your y is kind of behaving like your z, and that's exactly what B looks like. And that is a hyperboloid with one sheet. Can anyone tell me what D looks like? F. Yeah, so D is going to be F. It is going to look like a saddle. And it's a hyperbolic paraboloid. And that's because if you take y to be 0, you get one parabola, which is positive. If you take x to be 0, you get one parabola, which is negative. So that gives you the two parabolas in your hyperbolic paraboloid. And then if you take z to be 0 or z to be some constant, you get a hyperbola. So that is D. And okay, can anyone tell me what E looks like? Sorry, what? I'm not sure what you mean. Yes? Oh, H, that's what I said. Okay. Yes, it is H. It is a cone. You can tell that it's a cone again by, let's say, setting y to be 0, and you get z is equal to the square root of x squared, which is just going to give you a line, both positive and negative. And or you can set x to be 0 and see something similar. So that is a cone, and so we got our cone. Can anyone tell me what F what F looks like? A, yes. It is a elliptic paraboloid. It has an ellipse and then two parabolas. It is going in the y direction. And so we figured out F. Can anyone tell me what G looks like? E, good, it's a cylinder. It's basically a circle that you extend plus or minus infinity. How about H? Yeah, D, it's an ellipse. And we are done. Or ellipsoid. Okay, any questions about this?
Wait, what'd you say, F was?
F is the elliptic paraboloid. It's A.
Okay.
Okay, number 12. So they ask us which three of the following parameterizations are for the same curve. So let's try to understand what this curve looks like in its range as we vary t from positive to negative infinity. So for the first one, so we're in R2. So let's say this is our t, and we're trying to figure out how this curve looks. All we really need to tell is what does it look in its range? How does this cone look in its range? And that should tell us its shape, or we can actually draw the shape. So for t squared and t, as we vary t from plus or minus infinity, so negative infinity to infinity, what we get is that this goes from 0 so we get that it goes from 0 to infinity in the first coordinate and from negative infinity to infinity in the second coordinate. And if, okay, so if our t over here is in the y coordinate, then our t squared looks something like this. Okay, how about the second one? Cosine squared and cosine t. Well, cosine is bounded between -1 and 1. The first one is between 0 and 1, and the second coordinate is between -1 and 1. So these are definitely not going to be the same. What about the next one? So the next one, as t goes to positive infinity, both coordinates go to positive infinity. And as t goes to negative infinity, both of these coordinates are going to go to 0 and 0. So this is as t goes to negative infinity. Which means that we don't capture 0 because there isn't a t that you can give me that will get us to 0. And so again, this means that this one is not the same. The third one is not the same as the second or the first one. Okay, how about t and the square root of t? So as t goes to negative infinity, this doesn't really, the second coordinate doesn't really exist. And the first coordinate is going to again go plus or minus infinity. So again, not going to be the same as any of the ones before it. And because we know that 3 of the following must be the same, we know that the other last 2 have to be one of the other 4 that we've just seen. So when we're looking at the fourth one, we can write this as t minus 1, hello, oh, out of batteries. Okay. Okay, so the first part can be written as t minus 1 squared. And the second part we can just keep as t minus 1. So as we vary t from plus and minus infinity, so for the second coordinate, we go plus or minus infinity. And for the first coordinate, we go from 0 to infinity. Yeah, okay. So, because it's always positive, and so that will be the first one. So same thing for the first one. So these are the same. And so we can actually guess that this has to be the same as the first three, but we can also say same thing. As we vary this, the t cubed goes to plus or minus infinity, and the t to the 6 goes from 0 to infinity as we vary t from negative infinity to infinity. Any questions? Yes.
What would you say about the square?
Yeah, so the square root one, the first coordinate is going from negative infinity to infinity. So already doesn't really look the same in the first coordinate. And then the second coordinate doesn't exist when t is negative infinity or negative whatever. So any other questions? Okay, so problem 13. Okay, so they want you to give the parameterization of the intersection of this ellipse and this cylindrical paraboloid. So one way to think about this, so we have the first surface looks like x squared So the first surface looks like x squared plus y squared is equal to 1. And the second one is z is equal to y squared. Oh, okay, I'm going to do 14 and then I'm going to come back to 13. So when we have this, we can say, okay, I can take x to be cosine of t, right? I want this in terms of one variable. So if I take x to be cosine of t, and I take y to be sine of t, then I will get that if I plug them in here, we get 1. And then in order to find my z is just y squared, which is going to be sine of t squared. So my r of t is going to be cosine of t, sine of t, and sine of t squared. And then the second part of the question asks to set up the integral which calculates the arc length of this curve. So this curve is going for t between 0 and 2 pi. That's your circle. That's what it means to have a circle. So that's what your t is going to be. And we know that arc length, which is given by s, is equal to the integral from 0 to 2 pi, in this case, times the magnitude of r prime of t dt, which is going to be the integral from 0 to 2 pi times the square root of sine of t squared plus cosine of t squared, which becomes 1, plus 2 sine of t cosine of t squared dt, and this is going to be the integral from 0 to 2 pi of the square root of 1 plus 2 sine of t cosine of t squared. So that solves the first part of the problem. Any questions? Yes?
Yeah, where'd you get the sine?
You just take the derivative of this and then you square it. So that's just part of this formula. So if you take the derivative, the 2 comes down, you get sine of t, you take the derivative of sine of t in the chain rule, you get cosine of t, and then you square that whole thing. Yes, any other questions? Okay, so now, what is the curvature of this curve at the point 0, 1, 1? So first the question is, when do we hit 0, 1, 1? And that happens when cosine is equal to 0, which happens, and sine is equal to 1, which happens at pi over 2. So first the question then is, what is the curvature of pi at pi over 2? So the curvature at some time is the magnitude of r prime of t cross r double prime of t over the magnitude of r prime of t cubed. So we know what r prime of t is. R prime of t is going to be equal to negative sine of t cosine of t 2 sine of t cosine of t. So r double prime of t is equal to negative cosine of t, negative sine of t, 2 sine of t squared, and then a negative, let's put the negative here, plus 2 cosine of t squared. So r prime of pi over 2 is going to be negative 1, 0, and 0. And r double prime of pi over 2 is going to be 0, negative 1, and negative 2. Okay, so then when we do the cross product, we're taking the magnitude. So let's first take r prime of pi over 2 cross r double prime of pi over 2. And that's the cross product of I, j, k. Doesn't really matter. Negative 1, 0, 0, 0, negative 1, negative 2. And if you do this, you get 0, 2, and 1. So the magnitude of this vector is going to be the square root of 5. And that's going to be your curvature, because the curvature is this thing. So the curvature of pi over 2 is equal to the magnitude of r prime of pi over 2 cross r double prime of pi over 2 over the magnitude of r prime of pi over 2 cubed, but because that r prime is just this vector -1, whatever, its magnitude is 1. So this is just going to be the square root of 5. Any questions? Okay, let me see. Okay, so number 13 is very straightforward. Just take the derivatives of each component, find where you get this, this point. So this point comes about when t is equal to 4 square root 2, and then 4 squared is 8. No, 16 minus 4, 12. Yeah, so a t equal to 4. So take the derivative, plug in t is equal to 4 to r prime. So find r prime of 4, and then you write the line. So I'm not going to go into detail of how to do this. It's too similar to Calc 1. Any questions? Okay, so problem 15. Sorry. Problem 15, give a parameterization for the intersection of y is equal to x squared, z is equal to e to the x. So y is equal to x squared, z is equal to e to the x. So r of t is going to be, so we can take t to be, x to be t, and then y is going to be t squared, and z is going to be e to the t. So that is our parameterization. Okay, and then the next part of the question asks, set up an integral which calculates the arc length from 0, 0, 1 to 2, 4, and e to the 2. So the first one happens when t is equal to 0. That's when you get 0, 0, 1. Plug it in, 0, 0, 1. And then one of them had like e to the 2, right? And 2. So that happens when t is equal to 2. And so then our arc length s is going to be the integral from 0 to 2 of the square root of 1 plus 2t plus squared, 2t squared plus e to the t squared dt. And that's going to be our integral. Okay, the next part of the question asks, what is the curvature of this curve at this point? So at that point, t is equal to 0. T is equal to 0. So again, the curvature at 0 is going to be the magnitude, take r prime and then set it to 0, then cross it with r double prime, set that to be 0, and divide by the magnitude of r prime at 0 cubed. And I'm not going to go into the details of that. I'm just going to say, just so that you can check, that r prime at 0 is going to be 1, 0, 1, and r double prime at 0 is going to be 0, 2, 1. But again, take the derivatives, plug in your zeros, and then once you have this information, you can find the curvature. Yeah. The arc length has the magnitude, yeah. That's why you have the square root and the squares. Is that the question? So, any other questions? Okay. So let's see problem 16. So the position of the particle is given by this equation. What is the velocity of the particle? What is its speed and what is its acceleration? So position R of t is given by 3t squared minus 5t, 4 minus t squared, and 1 plus t, 3t. And the point that we're looking at is the point 2, 4, 7. So the point is 2, 4, 7. And that happens when t is so I wrote here 2. Give me a second. Okay, so the first part makes sense. What is, oh, 4t minus t squared. Okay, got it. Okay. Okay, so this will happen when t is equal, so we reach this point when t is equal to 2. If you plug it into the first coordinate, you're going to get 12 minus 10, second coordinate 8 minus 4, and third coordinate is going to be 1 plus 6. So then in order to find the velocity, we just take r prime and plug in 2. You can do that yourself. In order to find the speed, you just take the magnitude of the velocity. And in order to find the acceleration, you take r double prime at 2, and that's going to be your acceleration. Any questions? Okay, so that is problem 16. Problem 17 says the velocity of a particle is given by this equation. When t is equal to 1, the position of the particle is this. So you have some initial condition. Find the position function r of t. So your velocity, v of t, is equal to 2t minus 4, 3t squared, and 5. And your R1 of R1 is going to be 0, 2, 3. So R of t is going to be t squared minus 4t plus c1. The second one is t cubed plus c2. And the third one is 5t plus c3. So then your R1 is going to be a negative 3 plus c1. Your R2 is going to be, sorry, your second component is going to be c2. Oh, sorry, c2 plus 1. And your third component is going to be 5 plus c3. So then we have negative 3 plus c1 is equal to 0. So that implies c1 is equal to 3. C2, so 1 plus c2 is equal to 2. So that implies that c2 is equal to 1. And for c3, we get 5 plus C3 is equal to 3. So that implies that C3 is equal to -2. So once you get these constants, you can plug them back in here to get your R of t. Once you have your R of t, you can then find the acceleration of the particle, take the second derivative, figure out what point you're at, and finish the problem. Any questions? Okay. So the next prompt says the acceleration of a particle is given by this. The initial position when t equal to 0 is that. The position of the particle is that. Find the position of the particle when t is equal to 2. So very similar to the problem that we just did, except for you need to go from acceleration to velocity, put in the initial conditions for the velocity, which is given so you're not given the velocity directly. So you have to find the velocity. It will have some constants. And then assuming that this is going at a constant speed, you can find the initial conditions for the velocity. But otherwise, I am not 100% sure how to get the initial position of the particle when t is that, find the position of the particle. Okay. So in order to do 18, what you end up doing is, okay, let's just do A of t is equal to 6t, -4, and 8. So V of t is going to be equal to t squared, so 3t squared plus C1 -4 t plus C2 and 8t plus C3. And then your position R of t is going to be t cubed plus tc1 plus d1. And for the second part, you're going to get -2t squared plus c2 plus d2 and C2t. And for your last one, you're going to get 4t squared plus C3 t plus D3. Okay, so one of these is given, the position when t is equal to 1 is given here. And you can use that. Notice that when you put in t of r of 0, so this tc1 keeps canceling, and generally when the t in front of the c1 cancels the c1, the c2, and the c3. So for the first coordinate, we're going to get d1. For the second coordinate, we're going to get d2. And for the third coordinate, we are going to get d3. And that is equal to -1, -5, and 2. So that tells you what your d's are. And then you can plug in the t1. You can plug in your d's, plug in the t's, 1 or 1, And that will solve for your C1, C2, and C3, and that's how you get your R. And then you can plug in your 2 to finish the problem. Any questions about this? No? Okay. Okay, so problem 19. Let R of t be this. Calculate the unit tangent vector. So all you really need to remember is the formula for t, which is r prime of t over the magnitude of r prime of t. And then you just plug in 1. So that's simple. And then the second problem, calculate the arc length of this curve. So we've done this a couple of times. You use the formula. And so I'm going to move to problem 20. A drone is being flown along a set path. At a certain point along the path, the velocity of the drone is this vector over here. And the acceleration is this vector over here. What is the curvature of the path taken by the drone at this point? So we know that curvature, K of t, is equal to r prime of t cross r double prime of t over the magnitude of r prime of t cubed. Now, velocity is r prime and acceleration is r double prime. So that means that you can just rewrite this as your velocity is, so the magnitude of 2, 1, -2 cross your acceleration, -1, 0, 3 over the magnitude of 2, 1, -2 cubed. And then you just calculate what this is, and that gives you your answer. So that's it. Let me know if you have any questions, and good luck on the test tomorrow.